Thanks, Jim, for that introduction. And like you said, there's a lot of acronyms, so I'm going to try and spell out everything as much as I can and make sure I remember to say that. So my name is Calvin Yang. I'm an environmental scientist with the Surface Water Ambient Monitoring Program, or SWAMP, in the Office of Information Management and Analysis at the State Water Resources Control Board. And I'm here to give you an overview of SWAMP's Bioassessment program and SWAMP's resources. But before I begin, I just wanted to make sure I mentioned that the United States Environmental Protection Agency, or US EPA, provides a significant amount of funding to support the Bioassessment program and SWAMP's infrastructure. SWAMP also partners with US EPA on national monitoring activities to provide value to both statewide and national water quality assessments. So why is SWAMP involved in bioassessment? Well, SWAMP's mission is to provide resource managers, decision makers, and the public with timely, high-quality information to evaluate the conditions of all waters throughout California. And so in order to do that, SWAMP designs its monitoring to evaluate the physical, chemical, and biological integrity of the state's waters. And that's where the bioassessment program comes in for the biology side. And SWAMP has conducted bioassessments since 2000, and what you see on this slide is just pictures of the famous EPT, which were taken from the Bugs2Go, which is a digital resource that you can get on the SWAMP Bioassessment website. So to run the bioassessment program, SWAMP has many partners. So the California Department of Fish and Wildlife Aquatic Bioassessment Laboratory and the California State University Chico are the lead in designing, managing, and implementing the SWAMP statewide bioassessment program. And there's a picture of someone doing a CABW embeddedness measurement. The California State University San Marcos Laboratory serves as the lead for identifying benthic algae. And what you see in that picture in the middle is soft-bodied algae, which is taken from the soft-body stream algae identification tool. So, like the bugs, there's a digital resource of all the different algae that have been identified in swamp samples. And also, you've heard the acronym SWRCB, which stands for the Southern California Coastal Water Research Project. They are actually working on one of the things they're working on is a predictive statewide algae index called the Algal Stream Condition Index, or ASCI, for interpreting this benthic algae data. So SWAMP has two statewide monitoring programs because they focus on answering separate questions. So one of the programs is the Perennial Streams Assessment, or PSA. And what that program focuses on is assessing the condition or the status of the streams using a statistical survey design. And what you see in the map is the PSA divides the state up by PSA ecoregions, which are basically, in my way of simply explaining, is groupings of similar environmental regions. And the different pie charts represent the different CACI categories, the California Stream Condition Index assessment categories. And I'm just going to point out, let's see. There it is. So I'm just going to point out the statewide level. So statewide, there's about 44% of stream length which are in the likely intact biological condition, which is greater than or equal to 0.92. This yellow here, which is 22%, that's the likely or possibly altered. And then the red and orange represent the very likely altered CACI conditions. The other statewide program is the Reference Condition Monitoring Program, or RCMP, and that program focuses on streams with minimal human disturbance. And so one of the few criteria that they use to define a reference site is the number of road crossings, distance from dams, and the riparian disturbance index score, which is based on visual observations that you see at the site. So do you see bridges, Do you see trees cut down, or do you see pavement? So in addition to the statewide programs, all of the 9 regional boards, which is shown here on the map, they all have their own regional specific monitoring programs, and they've all incorporated bioassessment. And so what the arrow is pointing on to is a yellow colored shaded area, the Central Coast region. Regional staff there collected macroinvertebrate samples in order to establish limits for regulating sediment in the Pajaro River watershed, which this report is posted and available on SWRCB's website. In the Colorado River region, which is in the purple, regional staff out there conducted bioassessment on non-perennial streams because non-perennial streams make up the majority of stream length in that region. And part of the sampling included using data loggers to measure water depth for 2 to 3 years. And this report is also available online. The Los Angeles, Santa Ana, and San Diego regional boards, they all collaborate in the Southern California Stormwater Monitoring Coalition, or SMC, to evaluate biological condition in coastal watersheds. And the SMC is part of the PSA. And in this figure here, which I took from the SMC fact sheet, they looked at macroinvertebrates, soft algae, diatoms, and riparian habitat. And what this map is showing you is, based on those 4 different indices, how many of them indicated that the site was showed good biological condition. In the North Coast region, they have an active bioassessment program that focuses on regional reference sites, or reference conditions, and legacy timber harvest impacts. In the San Francisco Bay region, they have also a large collaborative monitoring program similar to the SMC called the Regional Monitoring Coalition, or RMC. I think this is a Region 2 sampling crew. In the Central Valley region, they're working on a new study to do some non-perennial stream monitoring in the Sierra foothills. And then in the La Hontan region, they were actually one of the first to start bioassessment, and they pushed to use it in many different applications. So all this monitoring data is available through the California Environmental Data Exchange Network, or CEDEN. And just to give you an idea of how much of this data is available, there are over 3,900 sites statewide that have been sampled for bioassessment at least once. And the data dates back as far as 1994, which predates SWRCB, but SWRCB has incorporated that data. In addition, there are also over 750 reference sites statewide, with the majority of them being in the Central Valley, La Hontan, and North Coast regions, but all the regional boards do have reference sites. And then here's just a few example data sets that you can download from CEDEN. The macroinvertebrate and algae data can be downloaded under the benthic category. And what you get in general is a description of the project, what collection method was used, and then the final identification and the count or the number of that organism was observed in the sample. For all the physical habitat survey data, that's all under the habitat category. And in this example, all the densitometer readings are reported by Transect. And then all of the water quality data, such as nutrients and field measurements you would take with a sonde, that's all located under the water quality category. So that was an overview of the SWRCB's bioassessment program. Now I'm going to go through an overview of SWRCB's resources. So the SWRCB Bioassessment website, which is this link here, is the best way you can access all of SWRCB's resources. In addition to the reports and the bugs to go that you saw in previous slides, there is also a field collection standard operating procedures, or SOP. There are scientific papers, and also instructions on how to use ArcGIS and R to calculate the CSEI yourself, which is here. And then just to point out, so this middle paper here is from the Western North American naturalists, which discovered the rare freshwater brown algae in California streams. And that was authored by the CSU San Marcos lab. Another resource that's on the SWAMP website is the interactive Bioassessment Scores Map, which displays all the sites that have been scored with the CSEI. And so these dots here in the middle, they represent the different CSEI categories, where the green is likely intact, and then the light green and orange are intermediate categories, and then the red are the very likely altered categories. On the outside of those dots, if algae was collected, these colors represent the Southern California Algae Index, or H20 scores, and those are color-coded similar to the CSEI, where green is likely intact and red is very likely altered. A new feature that's been recently added to this scores map is the eco-hydrology stream class layers, and this is a screenshot I took from that project. And so SWRCB and UC Davis recently completed a hydrologic classification of all streams in the state. So, and here's the 9 different classes that came up through this project. The classification system was developed to support a statewide effort to define environmental flow targets associated with maintaining healthy in-stream biological communities, and a scientific paper is in the works. So in this example, I zoomed in onto the Indian Creek in the San Diego region, which is located here. And it looks like you might be able to see this light blue color, but if you do see it, the light blue color represents that this stream is in the low volume snowmelt and rain stream class. When you click on a site, which is this here, a pop-up will appear showing all the site's metadata, what the most recent sample date was, and the CSEI score. If you click on this right arrow, the pop-up will display all the other constituents that were collected at that site on that day. So at this site on this day, algae was collected, turbidity, nutrients, and looks like there's more on the scroll bar, but that's what I'm just displaying right now. And then if you click on this link, more info, under the URL, a site or photograph of the site will actually appear as well. Also included on the SWAMP website are all of the past CABW presentations from last year through 2003. And like Jim was saying, it is interesting to see. So this is actually a screenshot I took from Jim's presentation back in 2003. The goal of CABW was to bring everyone together to talk about how to develop biocriteria in California. And you look at that back in 2003 to 2016 last year, where Pete Odie gave a presentation last year on how do we expand bioassessments for the next decade. So it's pretty interesting to see the progression of all the work that's been going on. And you'll also mention, I also want to mention that I did mention biocriteria because that's what it was called back in 2003, but it's now called the Biointegrity and Biostimulatory Policy, which Jesse Maxwell will give an update on later today. And then, like Jim was saying, all of the College of Bioassessment courses and course descriptions are also available on the SWAMP website, and it talks about everything from biological or bioassessment concepts to field and lab procedures and data analysis. So those were all existing resources, and SWAMP is working on developing new infrastructure to help standardized bioassessments in California. Later today, you'll hear from Andy Wren talk about his work on developing an index for physical habitat, which is pretty exciting. And also as exciting is SWRCB is also developing a statewide algae index that is analogous to the CACI, and it's projected to be available next year. And what I'm showing here is just the different testing that SWRCB is doing with the ASCI. In addition to the field SOP, which is available now, there is also a supplemental guidance document that contains additional field sampling information. So what this picture is showing here is a makeshift syringe scrubber that's ready for algae sampling. Just to mention Andy Wren again, he also did write a swamp technical memo that looked at how using multiple biological indicators, and he looked at macroinvertebrates, algae, physical habitat, and CRAM, how those all together provide, or how using multiple indicators provide a better assessment of condition than just using one indicator. And speaking of new things, I am actually working on a new tool, which is an interactive dashboard using Tableau software, which is available through this link if you're interested to look at. The purpose of this dashboard is to summarize data from the 2 statewide programs, the PSA and RCMP, and summarize it by regional board. And so just to explain what's or the way it's organized. So when you click on this link, you'll get a dashboard that looks like this. And the way you sort the data is see if I can yell. Better? Okay, so what you do is you use this first map to select by regional board to filter the data. And then this map populates based on what you select the data, or it displays the data that you select. And then on the right are is the legend of what the different colors and symbols mean. There's a checkboxes if you want to select just reference or just probabilistic sites. A drop-down menu if you want to select a specific CACI category. And then a slider if you want to look at a specific land use. And this table down here summarizes all the data that you selected. And what it does is it displays the different statistics, so the number of results, the minimum, medium, average, and maximum for all the different constituents, such as the CACI, chlorophyll A, ash-free dry mass, nutrients, chloride, and it says W1 Hall, and what that represents is the riparian disturbance index, which is and it's the symbol is just used, the symbol that's used is W1 Hall. So in this example, I selected on the Central Valley region, and I just wanted to look at just the reference sites in the Central Valley. And so the table populates based on my selection, and it shows that there's over 350 CACI scores for those sites, and almost 200 phosphorus results. In this example, I've filtered for just all of the urban sites statewide, and so you'll notice that there are 361 CACI scores for urban sites, and the average CACI score is in the very likely altered condition. And just some other measurements I wanted to point out. So the average conductivity for these sites was nearly 1,500 microsiemens per centimeter, and the average chloride result was 179 milligrams per liter. In this example, I filtered for just the forested sites and the possibly altered condition in the North Coast region. And for any site, you can actually just hover, move your pointer over the site, and a pop-up will appear showing the site's information. And if it is a probabilistic site, it will also show how much stream length is estimated by that site. And then if you wanted to just see just that site's information, you can just click on the site and it will just display the one site's results. And then in this example, I filtered for all the probabilistic sites in the Central Coast region. And they had 68 probabilistic sites, and their average CSCI score was in the possibly altered condition. And then in this example, I filtered for all the reference sites in the San Diego region. There are over 160 reference sites, and the average CSCI score for those sites were in the likely intact condition. So by going through all these different examples, I wanted to just show you that there are many different ways to explore the data, and that was my hope and the goal for this tool. So again, if you're interested, I would appreciate it too if you would give me feedback. But if you're interested, you can click on this link and check out the dashboard yourself. And I am still learning how to use Tableau. It's a new tool that I just recently received, but it's so far so good. I mean, I've still had to learn the new interface and how things work together, but you can always expand this dashboard and add more to it or change the analysis. So I would, if you're interested and if you like, please send me feedback on what you like and if it's a tool that you would find useful. Thank you.